Hi, everyone. Welcome back to Merle Advisor Channel, the home of all matters data handling, projects monitoring, evaluation, learning, and research. Today's learning is focused on big data. We all use smartphones every single day, but have you ever wondered just how much data these little devices generate? Every text message, phone call, email, photo, video, search, or song stream contributes to an enormous digital footprint. In fact, a single smartphone user generates nearly 40 exabytes of data every month. Now, imagine multiplying that number by over 5 billion smartphone users worldwide. That's a staggering amount of data, far too much for traditional computing systems to handle. And that's exactly what we mean when we talk about big data. To really understand the scale, think about what happens on the internet in just 1 minute. Millions of snaps are shared on Snapchat. Millions of people search on Google, log into Facebook, watch videos on YouTube, and send out hundreds of millions of emails. It's an overwhelming wave of information. But how do we decide whether all this qualifies as big data? That's explained through what's known as the 5 V's: volume, velocity, variety, veracity, and value. Let's break that down with an example from healthcare. Around the world, hospitals and clinics generate more than 2,000 exabytes of data every year through patient records, lab results, X-rays, MRIs, and more. The sheer volume is enormous. The velocity is incredibly high because this data is created and updated every second. The variety is wide since the data can be structured like spreadsheets, semi-structured like log files, or unstructured like medical images. The veracity is all about how accurate and trustworthy this data is. And finally, the value lies in what can be achieved when it's analyzed. Faster disease detection, improved treatment plans, and reduced healthcare costs. But how can we possibly store and process such a massive amount of information? This is where frameworks like Cassandra, Spark, and Hadoop step in. Hadoop, for instance, uses what's called the Hadoop Distributed File System, or HDFS. Here's how it works. Instead of storing a huge file in one place, Hadoop breaks it into smaller pieces and distributes them across multiple machines, making sure copies are stored in different nodes for safety. That way, if one machine fails, the data is still protected elsewhere. When it comes to processing, Hadoop uses something called the map-reduce technique. Think of it as taking a long, complicated task and dividing it into smaller jobs that can be completed at the same time by different machines. Once all the smaller tasks are done, the results are combined into a final answer. This parallel processing makes handling big data not only possible but efficient. And once the data is stored and processed, its applications are endless. In the gaming industry, for example, developers of titles like Halo 3 and Call of Duty analyze player behavior to see at which stages users pause, restart, or quit. This insight allows them to refine the storyline and enhance the gaming experience, ultimately reducing player drop-off. Similarly, during Hurricane Sandy in 2012, Big Data played a crucial role by helping experts predict the hurricane's landfall 5 days in advance, something that wasn't possible before, and supporting disaster management strategies along the U.S. East Coast. These examples make it clear when analyzed properly, big data is not just useful, it's transformative. Now let me leave you with a quick question. Which of the following statements about the Hadoop Distributed File System is not correct? First, HDFS is the storage layer of Hadoop. Second, data gets stored in a distributed manner. Third, HDFS performs parallel processing of data. And fourth, smaller chunks of data are stored on multiple data nodes. Think carefully and share your answer in the comments below. And finally, looking ahead, what do you think will be the most significant impact of big data in the future? I'd love to hear your thoughts. If you enjoyed this discussion, take a moment to subscribe, like, and share this video. Don't forget to hit the bell icon so you'll be notified the instant new content is released. And here's something exciting. We're launching a fans club very soon, where you'll have access to exclusive material, including programming codes and resources to sharpen your statistical skills with tools like R, Python, STATA, SPSS, SAS, and many more. So stay tuned, keep learning, and let's grow together.